Session is being recorded. Okay, good deal. It's first day of October 2020. Here we are in the South Business SBUS 1125 at doing our lab. We're going to do the lab 11.6.2 today, which is switchboard security stuff. And I got a couple of gotchas here. Let me see, am I sharing? Okay, I'm sharing what you guys here in the classroom are seeing on the overhead projector. I'm sharing to the recording as well. So here's the gotcha for today. The lab we're doing is 11.6.2. That's the one you're going to print out on your printer and do here in the classroom. But here's the gotcha about it. I'm going to go over here and bring up that Microsoft Word document that represents that file. And it says the first thing you're supposed to do is copy and paste in this pre-configuration for R1. Okay, but it assumes you have the slightly different model of the router where the interface ports are instead of G0/0 and G0/1, it's G000 and G001, so you can't paste it and you get errors. So, not to worry. I have put in a thing on here that says corrected R1 script. And if you click on that link, here's the one where I edited the file, and it says G01 instead of G0. So I'm going to take it, I'm going to copy it into the clipboard. So I'll copy it to the clipboard, do a Control-C, copy it to the clipboard, and I'll be ready to paste it into my R1. Now, before I do that, I want to do my suggested best practice. We've got a router and two switches, and the man in the middle is S1. What's my suggested best practice before you start doing anything and figure out you're on the wrong machine and you got the wires wrong? Well, I did the wires, you blame me for the wires. Is use Cisco Discovery Protocol, and I'm gonna give each device a host name, R1, S1, S2. I'm simply gonna give them a host name and do a no shutdown on that port. I don't have to put IP address on it yet. And then when I go to S1 and so show me my neighbors, I should see R1 up here. I should see S2 over there to make sure that my wiring is proper. Okay, so I'm going to go to my term and do that now, just as a proof of concept. My COM1 right now is connected to the router. And I'll need to swing my cable to the switch after I do this. I only have two connections on my machine. I don't have two machines. You guys got two machines. I'm the shoeless cobbler. I only got one machine. Now, the switches, all we have to do is give them a host name because switch ports are up and up automatically as long as there's a wire plugged into them. So, default host name of router. Looks like it's a router. I'll go to the privilege exec mode. I'll go to the global configuration mode, and I'll give them a host name of R1. And then I'll go to interface gigabit 0/1, I think it is in this lab. Yeah, 0/1. Not 001, but 01. And I'll just do a simple no shutdown. Don't have to do anything like IP addresses. Now, I'm ready to swing cable. I'm going to swing my plug over. Okay. I'll bring up my other term. So I'm connected to the top. The top term is going to be our S1, and the bottom one is going to be our S2. Your secondary machines here in the lab, in the physical lab today, you're just going to use your R1, and I just fired up the R1 on all of them just to make sure some of them hadn't been erased yet, and I erased them. What's up? Pardon? We're doing lab 11.6.2. This is switchboard configuration. Okay, so I'll go to the privilege exec mode, and I'll go to the global configuration mode. And all I got to do is give this guy a host name, so S1. And then I'll go to the second one. Well, I didn't really check to see if it was totally erased. I did earlier. But what are the two things you need to check on the switch to make sure it's totally erased? Well, we'll go to the privilege exec mode, and we'll show the startup configuration, and there's nothing there. And then we do the dir or show flash command. There should be no vlan.dat file present. And this meets those requirements. So I can go to the global configuration mode and give this guy a host name of S2. And if we wait just a second and go back to S1, if I do a show CDP neighbors, oops, I fingered it. It was switched before I changed it. So we can see that S1 S2 is the one I issued the command on. Wait a minute. S1 is the man in the middle. So S1's 0-1 port goes to S2's 0-1 port. That's what the lab schematic says on the front page. And then we have a connection that goes up to the router. No inter VLAN routing today, guys, just the standard stuff. Make it easy for you. So the port 5 on this switch, S1, goes to gigabit port 01 on the router, R1, and that matches the topology in the lab. And if you tried this, you should see the same thing on yours. Okay, good. Okay, so the network appears to be properly cabled. And he's going to give us a step-by-step. Now, this lab this is the instructor version of the lab. All the answers are filled in. There's nothing for you to answer except, it's like taking the SAT. You get 200 points for putting your name on the top of the paper and turning it in. So that's what you need to do. That's okay. I have my X-ray vision, Big Brother software. I can see what you're doing. The guys that are doing it at home will have to use Packet Tracer and send in a couple of screenshots of show commands to prove that they did it. Okay, still recording, still active. My microphone's still on. Okay, so I'm going to swing my wire back from R1. I got to swing my wire back to R1, and the first thing he's telling me to do is paste in that configuration. And remember, I copied that in a copy from my document that said corrected R1 script. It's in the Windows clipboard right now. So here we're back at R1. If I do a show, start, there's no configuration. DIR, you'll have to do this on a router. You don't have to worry about that VLAN.dat file. That won't affect us. It's only on switches. So what I want to do is go to edit, paste, and there in the clipboard is that corrected R1 script that I pasted, and I'm going to just click OK. And it worked. I didn't press enter at the end. There we go. If you'd attempted to put in the one that was in the laboratory, it would have come back with some errors because it says, oh, you said G000, G001. I don't have any of those. I just have G00, G01. Okay, so we completed the step. This is on, starts at the bottom of page 2. It says copy and paste the following configuration script into R1. That's been done. And then we're going to verify that with the command on R1, show IP interface brief. And it should say that. Now my print doesn't exactly match our routers because our routers have got extra serial ports and an extra 4-bit port in it. But you can see that the G01 port, 192.168.10.1, that matches. The loopback port, 10.10.1.1, that matches. You can't see the subnet mask. Show IP interface brief does not show you the subnet mask, but I like the command show protocol because it shows you it's a /24. The 192.168.10.1 is a /24. That loopback port is 10.10.1.1/24. You can see that on that easily. You don't have to go through and do a whole show run and look for all the lines. Okay, so we verified IP addresses and interfaces, and they're in the up and up state, and we don't need to do any troubleshooting. It's not necessary. So now I will go and do S3, and I'm going to swing my COM1 cable back from R1 to S1 because I need to configure the 2 switches now. Okay, so he's telling us that we need to configure both of them to have a host name of S1 and S2. I just did that a little bit in advance earlier just to prove with CDP, Cisco Discovery Protocol, that our wiring was proper. Okay, step 3, little b dot toward the bottom of page 3. I want to make sure that I do that step, no IP domain lookup, so that if I mistype a command, I don't get stuck for 2 minutes while waiting for that to take place. So I'll promote myself to the global configuration mode and say no IP domain lookup. And repeat that on switch S2. No IP domain lookup. Okay, next step, we're going to do some configuration, and he's giving you all the configuration for all this every step in this lab. So I'm jumping to the top of page 4. We go to switch 1, and he says we should go to interface F0/1. Description. I fingered it. Description. Link to S2. Interface F0/5, that should be the wire that goes up to the router, and this description is link to R1. And then port 6, interface Fast Ethernet 0/6, and that's the link to PCA. Description, link to PC-A. Those will show up later when we do a show interface status. I'll do show interface status. The nice thing about that is when you do show interface status, the new command that they're giving you now, it's been my secret Gonzo's secret insider tip for 20 years. They finally started putting it in the labs. You can show in the left-hand column, oh, look, the description's in there. So show interface status will show you whether it's up and up, what VLAN it's in, whether it's a trucking port, whether it's an access port, whether it's up and up, or whether nothing's connected to it. And in this case, it shows you what the description keyword that you keyed in earlier. So that's pretty cool. Now I'm going to go to S2 and do some similar stuff for S2. He's got a couple of links we need to worry about. The regular global configuration mode and interface Fast Ethernet 0/1 description keyword link to S1. Interface F0/18. Link to PC-B. Now, in the last lab that we did, our PCA and PCB were DHCP clients. They're still set that way. We'll double check that when we bring them up to make sure, when we get to that step. Okay, toward the top third of page 4, we still have a couple steps we need to do on both of these switches so that they can have connectivity, just like a host machine was. We need to set that default gateway value. The friendly neighborhood router for each one of these is, in fact, the router port that they're going to be connected to. So I'll go to the configuration mode on S1. IP default gateway is 192.168.10.1. And repeat that command on this one. The default gateway 92.168.10.1, is that correct for both of them? Okay. Okay, now we're going to create some VLANs. So on S1, I'm in the config mode, VLAN 10. Name, management. Do the same thing on the second one. VLAN 10, name, management. Step 2, right in the middle, starting the bottom half of page 4. We're going to create the management address. So configure, I'll go back to configure terminal. The recording still rolling. Okay, good. We're going to go interface VLAN 10. And he's been given an IP address of 92.168.10.201/24. Description, management, SVI, switch virtual interface. Do no shutdown. And then we're going to repeat that for the second one, slightly different IP address. Interface, VLAN 10, IP address 192.168.10.202. The other one was 201, wasn't it? Yeah, 202. Description keyword, management, switch virtual interface, shut down. Now, we're right near the bottom of page 4, step 3, bold step 3, configure VLAN 333. VLAN 333, name, native. Do the same thing on the other one. VLAN 333, name native. Okay, I'm on top of page 5, and we're going to create the VLAN 999s on both switches. This is going to be our garbage VLAN. Let's see if I can do it without having to drop back here. VLAN 999, and he takes it, name, parking lot. VLAN 999, name, parking lot. Okay, part 3, we're going to configure switch security, and we're going to trunk up the devices, change the native VLAN from the default of 1 to 333. So I'm in switch 1, and I'll say, can I say this interface FA0/1 without having to go back? Yeah, that works. Generally speaking, you can jump from one sub interface, sub global configuration mode to another without having to go back to the pure config and start again. Sometimes on packet tracer, it doesn't work right. You have to go back and do it. On a real machine, they will generally tolerate it. So I specified interface port 0/1 and switch port mode trunk, a command I like. And switch port trunk native VLAN 333. She was going to start freaking out because they don't match anymore. Oh. So let's see if I can do this here before all our error messages destroy everything on the screen. So I'm going to go interface F0/1. Maybe I should be in the configuration mode. Interface FA0/1, switch port mode trunk, and then switch port trunk native VLAN 333. And that should make the error message just stop coughing. Coughing stops. Okay, so we should have trunking up and present, and the official command is show interface trunk. And it says that port 1 is trunking. And it should agree with this on switch B. Show interface trunking, and it's that one. And the other way to check, I really prefer the other method, is show interface status. This does not work on packet tracer. If you do this on packet tracer, it will keep claiming that port FA01 is still in VLAN 1. But on the real machine, it actually works. So our port 01 of switch 1 goes to port 01 of the switch 2, and they're trunking with each other. They are linked to each other. And we can see the keyword description keywords we put in there, so we can keep track of it. Okay. Now, I mentioned switchport no negotiate in here before, but we're going to do it on this one just to be sure. Switchport no negotiate means don't listen to or try to transmit any dynamic trunking protocol stuff where the switches could link up and become a trunking port when you didn't really intend them to. And Cisco has changed their philosophy on this. 15 years ago, they were very aggressive. Switchport dynamic desirable. Now the default is switchport dynamic auto. I don't want any of that stuff on. I want it to be turned off completely, entirely. So I'll go to the configuration mode on S1 and specify interface port 0/1, which is our trunking port. Switchport, no negotiate, and repeat that on the second one. Interface fast. Ethernet 0/1, switchport, non-negotiable. Do not negotiate with terrorists or switch ports. Okay. I'm going to skip the show command. You guys can do that. Step 2, configure the access ports. So on switch 1, when we did this previously, we made switch 6 an access port and VLAN 10 or whatever the user VLAN was, and we made port 5. We made a trunking port to go up to the router. We were doing inter VLAN routing the last couple of labs. We're not doing that this lab. We're just going to make it a standard access port. So I'll go to the configuration mode. That's 1. I'm going to use the interface range command so I can do this in one fell swoop. So I'll say interface range fast Ethernet 0/536 config-if range. The prompt is changed to. Now whatever commands I type will take effect on both 5 and 6 at the same time. We'll switch port mode access. Port access VLAN 10. Yeah, it does it both at the same time. And then on S2, we just have one port. We have port 18, which goes to PC-B, just like we've been doing the whole semester. So interface F0/18. Port mode access and switchboard access VLAN. Was it also 10? It should be 10. Sorry, I messed up. Switchboard access VLAN 10. There we go. Okay, so they should be assigned to VLAN 10 now. So if I just show on the second switch, port 18 has been assigned to VLAN 10. I look on the first switch, show interface status. Port 5 and 6 have been assigned to VLAN 10. So they'll be able to connect to each other. I will leave as an exercise for the student, step 3, about disassembling the other ports and putting them in the garbage VLAN. So let's look at S1. I'm toward the bottom now of page 7. And we're going to look at the default port security because it's disabled by default. So I'll say show port security interface FA0/6. That goes to PCA. So it's disabled by default. So we're going to type in some commands now on S1 to put in some port security stuff. So I'm top half of the page of page 8, little .d step on S1. We're going to go to port 06. So I'll go to configuration mode, interface, fast Ethernet 0/6. We're going to type the command switchboard port security. Do that first. And then switchboard port security maximum of 3 different MAC addresses being allowed from that. Okay. Switchboard port security violation restrict. And then switchboard port security paging time 60. That's 60 seconds. And then switchboard aging type inactivity. Well, what is inactivity? That's when the dean goes off to a meeting for 3 hours at the opportunity center down there on 820. He doesn't come back for hours and hours. His PC in his office has gone into the inactive state. Okay, now let's repeat that command. Port security. Okay, I'll just have to type it. Show port security addresses. So the only one we put it on is port 6. He's still in VLAN 10. Sorry, what? Oh dear. Let me check it later after I finish this part here. At VMware's, like your VMware's, have they run out of time?
Yeah, I have a same issue.
Oh. Okay. Well, hang on. So we might not be able to use our PC as a V's again. What's today's date? I thought they ran out in March. I'll have to check and see. Mine's running. Okay, so just watch and chew when I do. Oh, man. Okay, now we're going to go on the top of page 9, and we're going to enable port security on S2. So I'm going to go down to S2, and I haven't done any savings. I haven't done any copy run start here. He doesn't say to do it, I'm going to go ahead and do it every few minutes, just in case someone pulls the plug or something comes loose. Okay, so I'm going to defer prompt on S2, and we're supposed to go to interface port F018. Okay, configure terminal interface fast Ethernet 0/18. And we're going to do the commands switch port security, turn it on gently, and then switch port MAC address sticky. The sticky one is what I like because you don't have to manually key in any MAC addresses. Switches memorize MAC addresses anyway. So let them memorize the address and then put it in the running configuration as a sticky, and you can save the configuration now. And if the bad guy gets in the wiring closet and pulls the plug on the switch, normally he would forget all the MAC addresses. But this way he remembers the ones that you have set security on, and that it'll work properly. Okay, so now we're supposed to do interface, port security, and 3 more commands here. Aging time. 60 seconds. Switch port security. Maximum 2. It was 3 on the last one. And then switch port security. Violation. Protect. Now, let's do that same show command, show port security, address. And we can see that VLAN 10 on switch 2, port 18 has been configured with these security things. Okay, do you remember DHCP snooping? DHCP snooping was the ability that you could specify certain ports that are trusted ports that were allowed to pass traffic from a DHCP server back to client machines as they requested an address when they came in the morning to boot up. Access ports that your employee and student PCs are connected to should not trust anybody. We don't want somebody to bring in, say, a Linksys router, and they plug it into their cube. And of course, Linksys routers are DHCP servers. We don't want those DHCP servers to mess up our company's DHCP server, which is incompatible. And we don't want them to be able to hand out those addresses. So this is Cisco's method of doing this. Another method you could use is the Microsoft Active Directory domain controllers. You can have authorized DHCP servers, and you can sort of put a lid on these rogue DHCP servers. Okay, so at the bottom, top of page 10, I'm going to go down to S2. Go to the configuration mode and turn on IP DHCP snoop. And then we're going to turn it on VLAN 10, which is our access ports on these devices. Now, one of the ports has to be a trusted port. All right, so that port that goes back from S2 to S1, port 1, from S2 goes back to S1. Switch to switch links, those are trusted. The employees generally can't plug into them. They can't get into the wiring closet. They have access to the plugs underneath the cubes and stuff. All those access ports, they're going to be in some VLAN 10. They're not a trunking port. We're going to not allow those to be trusted. But we need to trust our wires between the wires and the switches, between the switches and the routers, so that they can do this stuff. So we're gonna interface fast Ethernet 0/1. We're gonna trust this port. So IP DHCP snooping. Trust this guy. We can trust him. So I should be able to get an address from PCB now. You guys, I'm so sorry about you guys. I have to check on this VMware stuff. Let me go to my VMware. My VMware is running. What's the heck's going on here? In this case, you guys are the shoeless cobbler, and I'm not. Okay, so here I'm on PCB. And I'll bring up the DOS prompt. And if I go ipconfig, I've been granted the address. So should I be able to ping my 192.168.10.1, my default gateway? Yeah, I can ping it, okay. Now let's check on S2. Go back to S2. And he's having us type the show command, show IP DHCP snooping bindings. And we're not seeing the binding for some reason here. Let's go and do a step 6. Port fast, bridge protocol data unit data. guard. So normally, remember STP, 50 seconds, listening, learning, and finally blocking, and then finally forwarding data. So when you plug a wire into a switch, it can take 50 seconds before that light turns from orange, amber, back to green. But fast workstations these days, even back in the 90s, the secretaries, remember the old IBM PCs with the floppy disk drives? Yeah, that was before you were a gleam in your daddy's eye. They booted up in 5 seconds. And so the secretaries were plugged into the Novell network server, and the switch port wouldn't time out for 50 seconds, and they get an error message, and they call the help desk, and they would say, just press Control-Alt-Delete and boot it again. This time you'll get it right away. Well, that annoyed the secretaries. They didn't want to press Control-Alt-Delete again, the poor babies. So we would do port fast on that, spanning tree port fast, so that access port would come up right. Now, if you configure a port to be port fast, which means this goes to a client machine, it doesn't go to any other switch ports. He knows you lied to him or someone reconfigured it accidentally or on purpose to go to another switch port, because he'll start hearing bridge protocol data units. So the combination of these two commands, spanning tree port fast and bridge protocol, will fix this. I got to go back to my tier term. Number 1. And I'm going to go to the configuration mode, and then the interface, range, fast, Ethernet, 0/526. Spanning the port fast. Port fast. Warning, Will Robinson, says Cisco. If you turn on port fast, it should only go to access ports. If it goes to another hub or switch or something like that, you could cause a bridging loop. And what do we get when we get bridging and switching loops? We get broadcast storms. We do not want that to take place. Okay, so I'll do the same thing on the switch 2 on this port 18 is the only one that's in interface, fast Ethernet 0/18. Spanning tree, fast. And warning. Now we're going to go back and turn on the bridge protocol data unit guard, which means if I hear a bridge protocol data unit coming, and this is supposed to be an access port that goes to a desktop PC, and it never goes to another switch or another router. So if I hear any bridge protocol data units, I'm going to turn off the port fast and go back into the STP mode to protect my network against a broadcast storm just because somebody in the wiring calls it accidentally created a loop. Okay, on my switch number 1, I'm still in the interface range. I can't do it for the 5. I can't be in range because if I do it on 5, which goes up to the router, he'll see the router is another device and he'll freak out. So I'll do it like he says. I'll go configure terminal, interface, fast Ethernet 0/6, and spanning tree, BP2 guard, enable. Then on switch number 2, I think I'm still at that port 18. So I should be able to say spanning tree, BPDU guard. No, not to enable. Now, let's see what happened with our port number switch A here, PCA. PCB had an address. You could ping this default gateway. What happened to PCA? Give me a prompt here. ipconfig. Looks like I got an address. Can I ping my 192.168.10.1? I can. And what was the other PC? Is 10. Oh, we got an address from it. What was it? 10.11? I have to go back and check. It's not a static address anywhere. He's 10.11. So can I ping 10.11? Yeah, I can ping throughout there. Okay, good. I've gone through the whole thing here, and let me see. I need to stop recording.